There's a new virus in the database.
We have a zero bug attacking all login and overlay files.
Run antivirus. Give me a systems display.
Down 176 26.
In this episode, we'll be covering Google Cloud security and compliance fundamentals. I want to take you on a different journey than Microsoft today and check things from Google's perspective. We'll take a look on how Google Cloud secures its infrastructure using strategies such as defense in depth and zero trust. As you'll notice, that the cloud cybersecurity principles and strategies are all the same as we discussed in previous episodes. On the compliance side, we'll look at the different compliance standards and frameworks that Google Cloud is compliant with. Google has created a unique approach to shared security responsibilities and lately adapted the shared fate concept. We'll look at these ideas to get a better understanding of Google's responsibility and the customer's responsibility when it comes to security. Same as what we see in Microsoft platform, software, infrastructure as a service shared responsibilities. After that, we will look at Google's security key pillars applied to build a trusted infrastructure that doesn't rely on a single technology but has multiple stacks. We will get a better understanding of each of those stacks and how and where they are applied. Finally, we'll briefly cover aspects such as threat and vulnerability management from a Google infrastructure perspective. Anyone working within a cloud security domain requires both depth and breadth of knowledge and skills. As we will see, this is a different playground than the usual security concepts. As a Google Cloud security engineer who will be responsible for securing enterprise workloads, it's important that you gain a sound understanding of how Google secures its infrastructure first and foremost. So let's understand how Google Cloud doesn't rely on a single technology to make it secure, but rather builds progressive layers of security that deliver true defense in depth. Google applies zero trust principles, whereby there is no trust established between services, and multiple mechanisms are applied to establish this trust. All identities, whether they are users or services, are cryptographically authenticated, and only authorized applications are allowed to run. Google enforces Transport Layer Security (TLS) for its external exposed application programming interface (APIs) across all its network, and any data stored on Google Cloud is encrypted by default, or by applying technologies like Cloud Key Management, similar to Azure Key Vault. This makes things easier for the organizations, as it removes the overhead of managing encryption keys lifecycle management. Keeping that in mind, Google runs one of the most advanced security threat detection centers, which continuously monitors all services. With good protection from DDoS volumetric attacks, we're talking here layer 3 and 4, is applied by default as well. Google developed its own network hardware and software to enhance performance and security, resulting in a custom data center designs that incorporate various layers of physical and logical protection. To be able to do so, Google created what they called Titan, a custom security chip that offers cryptographic secure boot integrity and allows for both servers and peripherals to establish a hardware root of trust. Titan uses cryptographic signatures to validate low-level components such as BIOS, bootloader, kernel, and base OS image during each boot or update cycle. And by maintaining end-to-end control over the hardware and software stack, Google minimized the risk of third-party vendors as a threat vector and the supply chain attacks. Privacy being one of the biggest issues or challenges in security. Google Cloud has built-in privacy controls to earn back customers' trust. One of those services is Access Transparency. This service provides customers with the required visibility if and when Google employees try to access their environment. A keynote here: as a customer, you own and control your data. Not Google or any other provider should access your data or move it to other locations without your permission. So you, the customer, is the one responsible for securing access to your data. Security of the cloud and security in the cloud. Google shared fate concept. Security of the cloud refers to what the cloud service provider is responsible for. And security in the cloud is about the customer having the responsibility to use security products and services offered natively in the cloud or by a third party. The responsibility shifts typically based on the type of service being used. With the shared fate concept, Google aims to be more of an active partner as the customer deploy securely on Google Cloud, standing with customers from day one, helping them implement best practices for safety or safely migrating, and to provide assurance, most of all, that they will help customers not only when they are onboarded to the cloud, but also and if and when there are incidents or security incidents that require collaboration between Google and the customers. Google compliance commitments that all their products undergo various third-party independent assessments. In order to achieve appropriate certifications for standards and any other regulations. We're talking here PSI, DSS, ISO, SOC 2. If you go to cloud.google security compliance section and select Asia Pacific, for example, you will see all compliances for this region. For example, there's APP, Australian Privacy Principles, APRA CPS 231 and 234, and IRAP framework. IRAP is the Information Security Registers Assessors program, provides a framework for assessing and implementing effectiveness of an organization security controls against the Australian government security requirement. As outlined in the Information Security Manual, ISM, and Protective Security Policy Framework, PSPF. IRAP was created by the Australian Cybersecurity Centre, ASCS, which is part of the Australian Signals Directorate, ASD. For Google Defense in-depth strategies to be applied, their approach to implement a solid security by design, ensuring that multiple technology stacks are deployed to secure the environment and infrastructure, identity, and users. Google's operational security works on how they deploy services, codes, secure devices, and managing intrusion detection and insider threats. Conducting a two-way reviews for their code, including their own libraries to prevent introducing unwanted vulnerabilities such as XSS attacks, and identifying bugs and conducting static code analysis. Google has a very successful vulnerability rewards program for bug hunters. The BeyondCorp Enterprise, which is Google's zero trust solution. Google ensures that only authorized users have access to designated applications. This involves continuous monitoring of devices and users, regular patching and updates, enforcement of strong authentication measures, and complete utilization of the two-factor authentication 2FA. To address insider threat, all privileged users' access are actively monitored by a dedicated 24/7 IR team. Using complete secure automation for certain privileged actions to ensure safety and continuity. Once customers' information reaches Google's internal network, it is no longer in transit to the public-facing internet. When a service wants to make itself available on the internet, it can register itself with the GFE, Google front end. GFE performs many functions, such as ensuring that the correct TLS certificates are used and applied best practices, such as perfect forward secrecy and providing shielded protection against DDoS attacks. Google has multi-tier and multi-layer protection for DDoS to ensure that the services behind GFEs are protected from such attacks. On top of all that, there are multi-layers of load balancers that are both network and application aware. All these security controls together with Google's global scale infrastructure ensures that the largest of DDoS attacks will be absorbed. As we mentioned, Google ensures that data in transit and data at rest are both secure. You can choose to use the default encryption or use Cloud Key Management Service to import your own keys, bring your own key, which can perform the entire key lifecycle management, providing encryption such as FIPS 142 Level 3 protection, as this might be required in highly regulated environments. The biggest challenge with data security is that data must remain secure throughout its entire lifecycle. From its creation to when it's shared and stored and later analyzed and used to when it is deleted. And from large amount of the data leaks happening, this seems a hard task for many organizations. As part of Google Vulnerability Management Program, to keep its infrastructure secure from threat and cyber threat attacks, Google scans for threats and has automated penetration testing and security assurance programs. The aim is to ensure that if and when a security vulnerability is identified, it is proactively managed, contained, and eradicated. Identified vulnerabilities are assigned a priority based on their severity, and the respective teams or teams are assigned to mitigate and fix that vulnerability. The Google Safe browsing solution scans billions of URLs every day in order to find unsafe websites and then flag them to warn users. This technology is also built into Chrome browsers to warn users of potential malicious websites. VirusTotal, which is owned by Google, is a repository for viruses, trojans, backdoors, and any other malicious software you can imagine. Many adversaries modify their virus signature to avoid detection by endpoints protection tools. Therefore, Google uses multiple endpoint engines in products such as Google Drive and Gmail to effectively identify malware that may be missed by a single engine. In addition to Google Cloud Security, They have the Google Cloud Security AI Workbench, Google Vertex AI based on LLM, large language modules, and SecPalm, which helps in detecting and halting threats at the very beginning of the attack chain. Google's threat analysis group, with its research arm Project Zero, works by identifying security threats and making organizations aware of them. Google IR process is completely aligned with NIST SP 861 Revision 2 Computer Security Incident Handling Guide. Not only that helps Google being compliant, as many customers using Google Cloud have also adopted NIST module for handling incidents, making the entire end-to-end process streamlined. Now, between AWS, Microsoft, and Google is one of the more serious players and providers when it comes to cybersecurity incident response. Google's security incident response team is available 24/7 for any incident that may have impacted a customer. Google responds to the customer and helps and support the customer throughout the process to ensure the incident is resolved. With all that, this is just a tiny drop in Google's cloud security ocean, and we'll continue to provide more information in different episodes in this season as well. Thanks for listening so far, and have a wonderful day. Thank you.
Rising Cyber by Chad Sally B.